Now next we are going to discuss sulfur, its allotropic form, right? So sulfur, so its atomic number we know it is your 16, right? We know the electronic configuration. Now allotropic, there are a different form of allotropy of sulfur, okay, but yellow, rhombic and monoclinic is the main type. So the yellow rhombic, which is also called alpha sulfur, monoclinic beta sulfur. Now rhombic sulfur, so this is yellow in color, so yellow rhombic, right? And it is soluble in carbon sulfide. And recrystallization, so when you dissolve your roll sulfur in your carbon disulfide, okay, and if we do the recrystallization, then alpha sulfur is formed. Its specific gravity is 2.06, melting point 385.8 Kelvin. Now this rhombic sulfur, this is insoluble in water but soluble in benzene, alcohol, ether to some extent. Now next is monoclinic sulfur, beta form. It is colorless, okay, with needle shaped crystal. Now this is prepared by beta sulfur is prepared by recrystallization of alpha sulfur. Now beta sulfur is stable above 369 Kelvin and alpha sulfur is stable below 369 Kelvin. So alpha sulfur, यो 369 Kelvin भन्दा माथि के हुन्छ, it will decompose to beta sulfur. And यो 369 Kelvin मा both your beta and alpha sulfur is stable. So त्यसले गर्दा 369 Kelvin is what called transition temperature, where both form of sulfur are stable. Okay, so monoclinic beta sulfur, melting point 393 Kelvin, specific gravity 1.98, and this is soluble in carbon disulfide. Now next structure of sulfur molecules. Both rhombic and monoclinic sulfur have S8 molecule and it have crown shape, okay, crown like shape. This is your shape of S8 molecule, and other modification of sulfur are there, so which contain 6 to 20 sulfur atom per ring. Okay, so cyclose S6 ring have structure chair like structure. This is the structure for S6. At very high temperature, elevated temperature, approximately 1000 Kelvin, okay, that is in vapor state, your sulfur exists as S2, okay, and it exhibit paramagnetic in nature. So why sulfur similar to oxygen? We know oxygen is paramagnetic, right? So sulfur is also paramagnetic in nature, S2. Sulfur in vapor state is paramagnetic in nature because there it exists as S2 molecule. Now next is compound of sulfur. So first we'll start sulfur dioxide. What is the formula? SO2. What is the Lewis dot structure? It is similar to that of ozone. And its resonating structure, double will become single, single will become double, and the canonical form. So in sulfur dioxide, okay, the two bond SO bond are equivalent due to resonance. Okay, again the SO2 in SO2 two SO bond are equivalent because of resonance. Next is preparation. So it is prepared by burning of sulfur in air. So sulfur plus oxygen give sulfur dioxide. So this is solid, this is gas, you'll get this as gas. Okay, and in laboratory, okay, your sulfur is prepared by treating sulfuric acid and sulfite. Sulfite, when you treat this with acid, you will get is water and sulfur dioxide. Industrially, okay, so it is the byproduct during roasting. So we know we have done roasting, right? and here when we do the roasting of sulfide ore, right, we'll get is sulfur dioxide as a byproduct. Now this is colorless gas with pungent smell of burning sulfur. Okay, it liquefies at room temperature and under pressure, boils at 3 to 36 Kelvin. It is highly soluble in water. When it dissolves in water, what it gives, we have already discussed. It gives is sulfurous acid. So this is your acidic oxide, right? Then it reacts with sodium hydroxide. So it is your acidic oxide, right? So it will react with base. When it reacts with base, it will give salt, right? Sodium sulfite and water. Now this sodium sulfite further react with your sulfur dioxide to give sodium hydrogen sulfite. Okay, acid, base gives salt and water. Now it reacts with chlorine also. Okay, so when it reacts with chlorine, it produces sulfural chloride, SO2Cl2. Sulfural chloride. So sulfur dioxide will oxidize, right? Again we have discussed, to give sulfur trioxide in presence of vanadium pentaoxide. Now moist sulfur dioxide act as reducing agent and it reduces Fe plus 2 to Fe plus 3 to Fe plus 2 and your manganate, okay, permanganate to manganese ion. So you know the color of it, right? It is pink color. So when it reduces, color will become colorless. So that means what we can say is your moist sulfur dioxide, okay, will decolorize potassium permanganate, pink color. So ferric ion on reaction with sulfur dioxide, moist means ko huncha, water huncha. So kema convert huncha, Fe plus 3 will convert to Fe plus 2 and this will get oxidized to sulfate ion and hydrogen ion. Okay. And what again? So it also reduces permanganate ion. Moist means water huncha to manganese ion. The self will oxidize to again sulfate and hydrogen. And okay, so here the color is your pink. What will happen when you react it with moist sulfur dioxide? The color will become colorless. Why the color become colorless? Color become colorless because your permanganate, okay, will get reduced to manganese ion. Now next is uses. So it is used in refining petroleum, sugar, okay. Then it is anti-chlor, disinfectant, preservative act as. Then it is used in bleaching wool, silk. It in liquid form, right? It acts as a solvent. Then it is used in preparation of sulfuric acid, sodium hydrogen sulfide as we did. Then calcium hydrogen sulfite, okay, in industrial use. So this sulfur form number of oxoacids of formula H2SO4, H2SO3, H2S2O3, okay, H2S2O8, etc. Now we know the structure of sulfuric acid, right? What is the, so the sulfur, so it will have sp3 hybridization. So oxygen, 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 Then how many hydrogen? 2 hydrogen, and without hydrogen, oxygen will form double bond with sulfur. This is your sulfuric acid. Again, sulfurous acid, hybridization state is again same, right? How many oxygen are there? 3. Okay, and 2 hydrogen. So sulfur will not form direct bond with hydrogen. So this is the structure for sulfurous acid. Okay, then H2S2O7. How many S? 2. Oxygen 8, or even number. So there will be double bond oxygen oxygen. Okay, so this is peroxo disulfuric acid. Then oxygen 8, 3, 6, 7, 8. How many? Hydrogen 2. Then rest will have double bond with sulfur. Okay, these are the structure for different type of your oxoacids of sulfur. So last is sulfuric acid. So what is the formula of sulfuric acid? H2SO4. Just now we did the structure for sulfuric acid, right? It will have tetrahedral structure with 2 double bonded oxygen and 2 OH, right? So because of presence of ionizable to ionizable hydrogen ion, okay, the basicity, right, of this acid is 2. Now the properties, it is colorless, oily, greasy, dense, liquid, specific gravity 1.84, boiling point 611 Kelvin. Now this one will have high boiling point. Why? Because of intermolecular hydrogen bonding which is present in sulfuric acid. Now it have freezing point 283 Kelvin. So dissolution of this acid is highly exothermic, right? You have already done in your junior class. So for that reason, whenever you are diluting sulfuric acid or any acid in water, okay, that process has to be done very carefully, adding your acid in water with constant stirring, right? Now your this sulfuric acid is highly strong acidic in nature, we know that. Now your acidic in nature is because of release of your H plus ion, isn't it? And the release of H plus ion will occur in 2 steps. In first step, एउटा hydrogen ion release हुन्छ र hydrogen sulfate form हुन्छ ion. Then again this hydrogen sulfate ion will releases one more hydrogen and sulfate ion. So तिम्रो जुन चाहिँ दुईटा hydrogen will take place, okay, in 2 steps. Now this is the dissociation constant for this process, the dissociation constant for this process, okay. Now we know that sulfuric acid strong acid हो भनेपछि first H plus ion easily, okay, release भइहाल्छ. So dissociation of this, so Ki is very high. यो के हुन्छ Ki Ka1, it is very high. Why? Because it easily H plus ion release garcha. So once it releases H plus ion, it will convert to HSO4 minus, already minus. So the second step is slow step. भयो किन already minus एउटा आयो, minus ion is there, right? So from this H plus ion release गर्नु is difficult. That means this second process is slow and Ka2 is less here, right? So what we can say is Ka1 is more than your Ka2. Okay, so why Ka1 is large, very large compared to that of Ka2? Because first H plus ion will release with ACE, with much ACE, right? And second H plus ion will release with difficulty. For that reason Ka1 is much greater than Ka2. Now, so your concentrated sulfuric acid, it is strong dehydrating agent. भयो त्यसले गर्दा many wet gases कसरी dry गर्छ? By passing that gases through sulfuric acid. Now sulfuric acid removes water from organic compound also. जस्तै तिम्रो sugar which have formula 11, right? So this on treating with concentrated H2SO4 will turns black. Why? Because of formation of carbon and removal of all hydrogen and oxygen as water. This is what we call charring of sugar. Okay. So sulfuric acid is also used in manufacture of more volatile acid from their corresponding salt. Why? Because sulfuric acid have low volatility. For example, sulfuric acid, when you treat it with NaCl salt, you will get is HCl plus Na2SO4. So this is more volatile acid. So any salt, when it react with sulfuric acid, okay, what happens? It will give HX, double displacement reaction will occur, and MSO4. Next is your hot concentrated sulfuric acid act as moderately strong oxidizing agent. So त्यसले गर्दा यसले copper लाई oxidize गर्छ. Okay, concentrated hot H2SO4. It will oxidize copper to copper sulfate. Okay. And it forms copper sulfate, then sulfur dioxide and water. त्यसरी नै carbon, when you treat it with sulfuric acid hot and concentrated, carbon dioxide, sulfur dioxide and water. So sulfur लाई convert गरिदिन्छ, oxidize गरिदिन्छ, sulfur dioxide and water. Okay, so hot concentrated sulfuric acid oxidizes copper to copper sulfate, carbon to carbon dioxide, sulfur to sulfur dioxide. The byproduct के हुन्छ तिम्रो sulfur dioxide and water in all the cases. Now last is uses of your sulfuric acid. It is used in manufacture of fertilizers. It is used in petroleum refining, manufacture of paints, pigments, dyestuff intermediate. So in detergent industries, it is used in detergent industry, metallurgical application like in electroplating, galvanization, and in storage batteries, right? It is also used in manufacture of nitrocellulose product, and it is used as a laboratory agent. Okay, thank you all.